2.4 is going to be about deductive reasoning. So deductive reasoning is the process of reasoning logically from a given statement or facts to a conclusion. So you're going to look at a given statement and you're going to come to a conclusion. So law of detachment. If the hypothesis of a true conditional is true, then the conclusion is also true. If it is raining, then we will have gym class inside. It is raining today, so our conclusion is we're going to have gym class inside. So if a student gets an A on a final exam, then the student will pass the course. If Felicia got an A on her final exam, then our conclusion is going to be she will pass the course. It's the conclusion you can make based on the statements that are given. So if there is lightning, then it is not safe to be out in the open. Marla sees lightning on the soccer field, so our conclusion is Marla isn't safe on the soccer field because there was lightning. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. Ray RS divides angle ARB so that angle ARS is congruent to angle SRB. So then we would say ray RS is an angle bisector. Law of sigillism allows you to make a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis of the other statement. Okay, so if it is July, then you're on summer vacation. This is how it attaches. So if you're on summer vacation, then you work at a smoothie shop, so you can attach your hypothesis and your conclusion of your first statement and your second statement. So if it is July, then you're going to work in the smoothie shop. So you always attach, if your conclusion and your hypothesis of the two sentences are true, that means your hypothesis and other conclusion should also work. So if an integer ends in 0, then it is divisible by 10. If an integer is divisible by 10, then it is divisible by 5. So we can do our hypothesis and our conclusion from our first sentence to our second sentence. So an integer ends in 0, then it is also divisible by 5. So if an animal is a Florida panther, then its scientific name is Puma concolor cori. If an animal is a Puma concolor cori, then it is endangered. So we attach our front end and our back end because they share this. So I'm going to pause this and I'm going to write out, if an animal is a Florida panther, then it is endangered. So we attach our front end and our back end because that's true. If a line intersects a segment at its midpoint, then the line bisects a segment. If a line bisects a segment, so they share, then it divides the segment into two congruent segments. So we're going to connect these two. So I'm going to pause and write my sentence. Okay, so if a line intersects a segment at its midpoint, then it divides the segment into two congruent segments. If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. Okay, this does not connect, so we don't have a conclusion. Okay, your conclusion of your first conditional has to match your hypothesis of your second conditional for you to make a conclusion. So if a whole number ends in 6, then it's divisible by 2. If a whole number ends in 4, then it's divisible by 2. They don't connect, so we cannot make another conclusion.